Good evening to all of you. So today we are going to start with the current electricity. Today and tomorrow we'd like to finish the current electricity chapter, right? After that we'll come back to the remaining part of electrostatics in the next Friday's class, and the capacitance we'll discuss in the next Friday's class. Okay? So I hope all of you are ready for this part test 2, and I hope all of you are aware of the syllabus also. What is the syllabus for this part test? Very good. Yes. Means motion in a straight line, motion in a plane. Means projectile, circular, and motion in a straight line. Okay? Great. So today we are going to study the concept of current electricity. I hope you know what is current. It is defined as the rate of flow of the charge. So if we divide a conductor into two parts with the help of an imaginary plane, what do we notice? That when the potential difference is applied through the imaginary plane, a specific amount of charge will pass in a specific direction in a given interval of time. So if the q amount of charge passes through it and the time taken is t, then it will be called I is equal to q by t. The SI unit of current is what? Amperes, and 1 ampere is 1 coulomb per second. I hope you understand the currents are of two types. One is DC, in which the current is constant, right? Other is AC, in which the current is variable. Our present focus is on DC current, the current which remains constant with time, right? We'll study about the AC current later when we'll discuss EMI. After that, we'll discuss AC. Right? Now we know that there are two ways to look at the current. One is called the macroscopic view. In the macroscopic view, our focus is on dq by dt, means the amount of charge dq must pass through the conductor in the time dt. Other is called the microscopic view. In the microscopic view, we are talking about the drifting of the electron. Drifting means what? When the potential difference is applied, then it creates electric field, and due to that electric field, the electrons acquire a net drift velocity by which the electrons drift opposite to the direction of applied electric field. I hope it is clear to all of you. And you know the formula. Here small n represents what? Number density of free electrons. Capital A represents what? Cross-sectional area. Vd represents what? Drift speed or drift velocity. Because we are writing in the scalar form, that is why we write drift speed here. If I write in the vector form, then it will be called drift velocity. And a small e represents the charge held by the electron. Okay. Now, when we talk about a conductor of non-uniform cross-section, you can write it. So change in the cross-sectional area does not affect the current flow, because the different sections of the conductor, if I consider them to have different resistances, still those conductors will remain in series. So the value of current will remain constant. But the concept of electric field will change, drift velocity will change, current density will change. All these quantities are inversely proportional to the cross-sectional area. Hence, these quantities will change. So this type of MCQ will be there where you have to answer it. Okay, Adi Sinha is there. Ameya Wankhede.
Yes, sir.
Harsh.
Yes, sir.
Kameshwaran.
Present, sir.
Lohit.
Present, sir.
Yes, sir.
Rohit C.
Present, sir.
Samir Ahmad.
Present, sir.
Shamal Dwivedi.
Yes, sir.
Sultan.
Present, sir.
Tejasvi. Krishna Mitra.
Yes, sir.
Alan,
Present, sir.
Amita Shaji,
Present, sir.
Annapurni, Anvi, Anna,
Present, sir.
Ardra, Bijulal,
Present, sir.
Darshini Perumal, Divyadarshini,
Yes, sir.
Isha,
Present, sir.
Harini, Uma Magesh,
Present, sir.
Krishna,
Present, sir.
Nuha Nazrul Haq, Pranav Vinod,
Present, sir.
Rejoina Pauline,
Present, sir.
Sabah Khadija, Sai Shri Vaishnavi, Sai Shriya, Shakti,
Present, sir.
Shreya Satish,
Present, sir.
Siddharth Sunil,
Present, sir.
Syed Arsh,
Sir, this is Sabah. I'm there. My mic wasn't working.
okay, Sabah Khadija, right? I'll once again call the name of the
Yes,
students
sir.
I have marked absent. Adi Sinha, Tejasvi, Annapurni, Darshini Perumal, Nuha,
Sir, I joined the class now.
who? Nuha?
Nuha.
Okay. Sai Shri Vaishnavi, Sai Shri Rajgopal, Syed Arsh, okay. So have you written this information? Yes, tell me. Current remains constant, I remains constant, and the drift velocity is inversely proportional to the area of cross section.
So since the class is recorded, will be uploaded later.
No.
Okay.
It is just to check what I missed in the class. I hear it again and then I include in the next class. Then I delete it because we are not supposed to keep it.
Okay. Yes.
Okay, have you written? Okay. Now I hope you understand that there is a term called current density. What is it? It is current per unit area. It is a vector quantity and it can be written as I equal to J vector dot A vector. And the Ohm's law, there are two forms of Ohm's law. One is called the scalar form. In the scalar form, I is directly proportional to V. And in the vector form, this is the scalar form. And we also have the vector form in which we write J vector is equal to sigma into E. That is called the vector form. Okay, what is sigma? Sigma is called the conductivity, reciprocal of resistivity, 1 by rho.
Yes.
Is that clear? Okay. And I hope you understand there is a term called R over here. R is known as the resistance. And how the resistance is defined is the ratio of a potential difference, that is V, and the current, that is I. And this is the experimental setup. Many times the questions are asked based on the practical physics. In that, Ohm's law question is there. So I hope you recognize all the elements, right? This element is what? This is voltmeter, because it is connected in parallel to the circuit. Do you notice it? This element is ammeter, because it is connected in series with the circuit. This element
Yeah.
is rheostat, right? Okay. And this is the source of EMF, correct? And between these 2 points, the resistor is present. The voltmeter is present across the resistor. Do you understand it? So this is the equivalent diagram. I hope you understand it. And the resistance will be defined as potential difference across the conductor divided by the current. R will be equal to V divided. And I hope you understand the resistivity of a material, R equal to rho L by A, where rho is called the resistivity of the material. The SI unit is ohm into meter. Any difficulty so far? No? Just to brush up, we are doing it these concepts. I hope already you have. So R is defined as rho into L by A. I hope you know it, right? And in the terms of the microscopic terms, it can be written as ml by ne square A tau, where small n represents what? The number density of free electrons, or number of electrons per unit volume. And here rho is the resistivity, that is m by ne square tau, and that is equal to 1 by sigma. Okay? Any difficulties there? Okay. Now let us practice with a very small question. We have to find the resistance of a cuboidal box. Means there is a cuboidal shaped conductor whose resistivity is rho, which is uniform, but its dimension is A into B into C. Means along the x-axis, its distance is A. Along the y-axis, the distance is B. Along the z-axis, the distance is C. Can you understand it? Now the current I1 is supposed to pass through the conductor along the x-axis. I2 is supposed to pass through the conductor along the y-axis, and I3 is supposed to pass through the conductor along the z-axis. So can you find the value of R1? That is the resistance along the x-axis. Have you understood what is shown in the diagram? There is a cuboid, and in that cuboid, there are arms of length A along the x-axis, length B along the y-axis, and length C along the z-axis.
Rho A by BC.
Very good. That is for Rx. Excellent. Wow. Very good. What about R2 or Ry?
Rho B by
Bolo
AC.
Rho
AC.
B by AC. Very good.
By
Excellent.
AB.
And what will be R3? Rho C by AB. Very good. Excellent. Any problem to anyone? So R1 will be rho A by BC. R2 will be rho B by AC. And R3 will be rho C by AB. Is there any problem? Anyone having any difficulty? Please ask. Yes, all of you are able to understand?
Yes.
Can we move ahead?
Yes, sir.
Yes, sir.
Okay, let us see another question. We have to find the equivalent resistance of a thick cylinder having the inner radius of R1, as you can see in the diagram here, outer radius of R2, as you can see in the diagram here, and the length is L, as you can see the diagram here. If the current is parallel to its length, it means the current is flowing like this. Then what will be its resistance? Yes, tell the answer. What will be the value of resistance?
Rho L by pi capital R2 square minus R1.
Rho L divided by pi into R2 square minus R1 square. Very good, excellent. The idea is clear in the mind, or any difficulty is there? No? So now can we increase the temperature a little bit?
So can you show the question once?
Yes, this is the question.
Okay.
Okay, it is important to note that the current is flowing parallel to its length. Okay, can we move ahead?
Yes.
Yes, sir.
Have you understood? This will be the answer. Rho L by A. The area of cross section in this case will be pi into R2 square minus R1 square, and length L will be the length along which the current is flowing. Okay, now the same question is there. Inner radius is R1, outer radius is R2, but now the current flows radially outwards. Can you understand it? Due to some mechanism, in the hollow portion, we have a higher potential, and the outer surface is having a lower potential. The current is flowing radially outwards. Now we have to find the value of resistance. What is the problem? Earlier, when we considered its cross section, what I found? I found a uniform cross sectional area, right? When I try to cut it, I find that wherever I make a cut, I find the same area, and that is pi into R2 square minus R1 square. Now in this case, the area of cross section is not uniform. Can you understand it? Can you imagine in your mind? So if I go to a distance x, I see an area of 2 pi x into L. That is the area through which the current is passing. And the thickness through which the current is passing is dx. So we have to find the value of the resistance. So in this case, R will be integral of dr. Because all those elements that we are going to consider, they are connected in series. Can you imagine in your mind? Different layers of cylinder. Can you imagine? Yes?
Yes.
So all those layers through which the current is passing, they are in series. So R can be written as integral of dr, and the value of dr will be what? Rho into the thickness through which the current is flowing, that is dx, divided by 2 pi x into L. Now here x is a variable, and the minimum value of x is R1, and the maximum value of x is R2. This value of a resistance. Is the question clear, and how we have to proceed? Yes, tell me. Rho into log नहीं बोलते, ln बोलते, ln of R2 by 1. Very good, excellent. Wow. Any difficulty to anyone? Any problem is there? All of you understood? Yes?
Yes.
Yes, sir.
This is the area through which the current is flowing. See, if I open the cylinder, I get a rectangle, right? And it is having a thickness of dx through which the current is flowing. So for time being, let us cut it. Let us make it flat. So we'll see how much. 2 pi x, that will be the circumference, multiplied by L. That will be the whole area through which the current is passing. Through how much thickness it is passing at a moment? Through a thickness of dx. Is it clear? All of you are able to understand it? Or any problem is there? Can we move ahead?
Yes, sir.
Very good. The questions are easy to digest or very difficult to digest? Easy? Okay. Now try this one. There is a thick spherical shell having the radii R1 and R2. Means inner radius is R1, as you can see here. Outer radius is R2. And the current is flowing radially outwards. I hope you can easily understand again. From the center, if I go to a distance x, I can cut a small element of thickness dx. And again, R will be what? Integral of dr. Why? Because all the elements will be in series. So R will be integral of dr. Try to think what will be dr and then try to find the value of R.
After that, the limits. So, x square going this r2 square r1 square instead of replace it with x square. Integral of x raised to n is equal to x raised to n plus 1 by n plus 1. Yeah, minus it on inside, then r1 minus r1 minus n.
Yes.
If you answer rho by 4 pi 1 by r1 minus 1 by r2.
Excellent. Wow. Very good. Good. Well done. So all of you can understand that the area through which the current will pass will be 4 pi x square, right? And the thickness through which it will pass will be dx. Rho is constant, 4 pi is constant. Integral of 1 by x square dx is minus 1 by x. When you put the limit, it will be rho by 4 pi into 1 by r1 minus 1 by r2. Okay? And let me remind to you, the similar questions can be asked in a heat conduction also. Here we are talking about the conduction of electric current. Exactly similar question can be asked for heat conduction also. In heat, it is easier to imagine that there is a heat source inside that cavity, and from there the heat is coming out. Or I have put water inside that cavity. Outside I have kept ice or something. Then the heat will be radiated and the water will freeze, and rate at which water is freezing. Many different types of questions can be asked there. Okay? So do you understand how we got the resistance in this case?
Yes.
Any difficulties there? Okay. Now let us talk about a frustum here. We have to find the equivalent resistance of a frustum having the radii A and B. On the left side, the radius is A. On the right side, radius is B. Length is L, and the current is flowing parallel to the length, as you can see here. Again, I hope you can see that if there is a small section and if it is having a resistance of dr, r will be integral of dr. But here we have more variables to deal with. So far, the systems that we have dealt is having only one variable. Now it is having multiple variables. The radius r that you see here is itself a variable. The distance from one end, if you consider, that is also a variable. If I consider this distance to be x, that will be another variable. This will be the thickness dx through which it will pass. And the area of cross section through which it will be passing will be pi r square. Is the question clear?
Yes.
What is the? We are talking about a small section. The small section will be circular because the radius is gradually increasing from one side to the other side. Okay, it is like this. At one end, radius is less, other end radius is more. So when I'm talking about a small cross section, that cross section can be considered to be cylindrical. So that area will be pi r square. R variable is introduced there. But that r and x, they are two different variables. So you have to find a relationship between the two variables. Only then you can proceed to find the value of the resistance.
Should we find the area gradient or something like that?
Now you have to think. I have just guided you with enough number of examples. That is for you to find. I'm still telling you, guiding you. I'm telling that there is a relationship that you have to find between the two variables. What are the two variables? X and R. If you have studied a straight line, then you can see a straight line also here. This will be X and this will be R minus A. And this will be B minus A. So in your mind, you can think that this is the origin and this is a straight line passing through it, through the point 0, 0, then through the point X, R minus A, then through the point L, B minus A. You can't find a relationship between R and X? ये 1 मिनट में तो क्वेश्चन खत्म करके आगे बढ़ना है. Yes, Adi Sinha, you are able to understand the question?
Yeah, sir. So
So can you tell me what will be the resistance of a small section of the conductor, dr?
Sir, K dx by A.
It is not K, it is rho.
Yeah, 1 by rho.
We use the term resistivity rho. Into thickness will be dx. And what will be the area of cross section? That will be pi r square. We are considering r as a variable. Now, how r and x will be related? That is the second question.
Sir, we use similar triangle thread to find the
Similar triangle, बिल्कुल similar triangle use कर सकते हैं. तो जल्दी करो ना, आगे बढ़ो ना.
I was doing that. I was feeling like I told you this is
Listen to me.
Similar triangle करो, straight line का equation लिखो. This is the angle theta. You can slope intercept form लिख सकते हो. There are so many different ways. I told you very clearly that this is the x-axis, this is the y-axis, this is the origin 0, 0. I gave you the coordinate points through which the straight line is passing. What else do you want for writing the equation of a straight line? Three points we have identified. It is passing through 0, 0, through x, r minus a, through l, b minus a. What else do you want? Yes, do you understand? We will get this. R minus a by x is equal to b minus a by l. That is the value of tan theta in the two triangles, or the ratio of the corresponding sides of the two triangles. Or this is the equation of the straight line. Y by x is equal to m. That will give us this relation. R is equal to b minus a by l into x. If I differentiate, r will become dr, x will become dx, and derivative of a will be 0. So this is the value of dx in terms of dr. And in place of dx, we can put this variable. And the value of r will change from a to b. Yes, Harsh, you are able to understand or not?
Yes, sir.
So please respond and please give the
Yes.
answer. You have joined online, it's okay, but you have to respond in the same proportion to show you are present in the class.
Yes, sir.
It's rho L by AB. Pi AB.
Yes, very good. Excellent. Understood?
Yes, sir.
The result will be rho L divided by pi A. Okay? Any problem to anyone?
No, sir.
Yes, all of you understood?
Yes.
Okay. Now we know that for the Ohm's law, I is directly proportional to V. And according to that, there is a straight line behavior between the ohmic conductor. Correct? Yes? Any problem is there? No? But sometimes the question is asked to identify the given non-ohmic element of the conductor. So it is important for us to understand how the variation of the current takes place with the potential for other elements. Right? For a conductor, it is a straight line, right? We keep on increasing the voltage, current will keep on increasing. We keep on increasing the voltage in the opposite direction, current will keep on increasing. There is no doubt about it. It will always remain a straight line. As long as it obeys the Ohm's law, it has to remain a straight line. Now, this is a filament lamp. What is a filament lamp? You must have seen something like this, the bulb. In this case, what do we notice? This dotted line represents the ohmic conductor. But it is not an ohmic conductor. It is behaving like an ohmic conductor only for a small value of current in the two directions. Do you see it? As the value of current increases, its deviation is observed from the Ohm's law. Okay, so you can write it. So they will ask this as a graph, and they will ask this is a current potential difference relationship for which element? 4 options will be given. So which element you will choose here? Filament lamp. I hope you understand what is filament lamp. Nowadays you don't see the bulbs like this, but in your childhood you must have seen the bulbs like this, right? Still at very few places this type of bulb is there. Yes, Eva? Have you seen a bulb? The glass thing. Inside that there is a tungsten filament which glows. That is what it is. Nowadays we don't see. Nowadays we see the tube lights and the CFL. CFL also we don't see now. We see the LED bulbs, right? Okay, understood?
Yes.
Very good. Now this is a semiconductor diode. What is the symbol? This is the symbol for a diode. The triangular section represents the P section, and the straight line represents the N section. Actually, it is called PN junction diode. This is the graph. What do you notice here? There is no linear part of the graph, right? This part is called forward characteristic, and this part is called reverse characteristic. Yes, very good. And if you have done Zener diode, then there is a sudden fall in the value of the current.
There are all diodes semiconductors.
Yes, diodes are made up of semiconductors. That is what we study. In old time, we had vacuum tube diodes. That is why you must have heard the story that we had big computers. Many images you must have seen that this was the 10 MB device being loaded into a truck in the year, कुछ भी year लिख देते हैं. नहीं, 1950. Okay?
So, but in the textbook, a different graph shown.
There are different parts of the graph. This is the standard behavior of the diode.
All right.
Okay? Now there is an element called thermistor. Thermistor means whose temperature changes with temperature, whose resistance changes with temperature. So this dotted line represents what? The ideal behavior. And this is just the reverse of the tungsten filament. Do you see it? In the case of tungsten filament, the deviation had happened here and deviation had happened here. Do you remember it?
Yes.
And in the case of thermistor, the deviation is just in the opposite direction. Then we have
Finish
electrolyte.
the graph for 1 second.
It is just the reverse of the
So just confirming,
tungsten
thermistor is when the resistance changes with temperature, right?
resistance changes.
Okay, thank you, sir.
And it is having multiple type of applications. You can see it here. There is positive, there is negative, there is NTC, that is negative temperature coefficient type thermistor. There is PTC, that is positive temperature coefficient type thermistor. Right? In the case of NTC, the resistance decreases when the temperature rises. In the case of PTC, resistance increases as the temperature rises. Okay? You don't have to know all this, but these are the things which you see and you have to understand. Now this is electrolyte. You must have seen. Pocati sweet is sold here, right? I found this diagram. I found it. Smart water. This is the behavior. Now what do you notice? It does not pass through the 0, 0. The current will start only at a specific value of voltage. Between 0 and that specific value, there is no current. But once the current starts, it is having a linear behavior in both the directions.
Not all electrolytes will show the same.
Huh? It is the rough. If this type of diagram, these are the diagrams which have been asked earlier in the exam. Those diagrams I have tried to find a similar diagram on the net and I put it here. All these things I am discussing is based on what has been asked earlier. Those concepts I have tried to put in the PowerPoint. And I'm posting the past year NEET and JEE questions also. So those who are preparing for JEE should go very religiously through each and every question, because question, answer. In this format it is given. Topic wise, it is given there, right? So please devote your time, because this is the time. Let me tell you very clearly that you have another 2 months time for you to come in the actual competition. To be very frank, right now you are not in the competition. You have the intention of preparing for the JEE or preparing for NEET. But right now, the type of scores that you are getting is not taking you to a correct place. JEE means you want to go to IIT. The scores that you are getting now is not taking you to IIT. Do you understand it? Right? Similarly, those who are preparing for NEET, their goal is to go to a good college, preferably AIMS or the best of the medical college. Right now, the scores those preparing for NEET are getting is not taking you there. But still, you have the time to work on your skills, right? To work, practice the more number of questions and to improve your skills, improve your score. Correct? And the best method is that if you are giving half an hour for each subject every day for practicing the past year questions, 30-minute time if you give, and you try to practice 20 questions, 25 questions, because question answer both are given. You don't have to put a lot of effort for that, right? So if you keep on doing that, at the end of a month, you will be quite improved. Do you understand? Every day, if you are able to do at least 20 questions, at the end of 1 month, for each subject, you must have done 600 questions. At the end of 3 months, you must have done 2000 questions. Do you understand it? And if you keep on revising those questions again, you can definitely get a very good rank. Okay. So you understood this graph. So what is the conclusion? The conclusion is that Ohm's law is a special case of the resistance behavior. Most of the electronic components are non-ohmic. Okay. Now, what is the effect of temperature on the resistance of a metallic conductor? What diagram do you see here? If the wire is cold, then here the red dots are representing the atoms. So atoms are stationary and the electrons are mobile. Of course, the electrons will suffer collision, energy will be lost, and the resistance will be offered by the conductor. But if the wire is hot or the warm wire, what difference do you notice now? The atoms are also vibrating, electrons are also moving. So in which case the probability of collision is more between the electron and the atom? Yes?
Warm wire. Yes,
तुम
Avi.
लोगों को एनिमेशन दिख रहा है नहीं दिख रहा है?
Yes.
You're able to see the oscillating particles? Okay. Very good. Okay. So in the case of warm wire, the probability of collision will be more, and we can say that as the temperature will increase, the resistance will increase for the conductors. Any doubt? Any problem? Very good. But for the semiconductor, what do we notice? When the temperature is raised, the greater vibration of atom breaks the bond, and then the more electrons are available. So when the temperature will increase, the resistance will decrease for semiconductors. In general, if the coefficient of thermal resistance is a function of temperature alone, then the final resistance will be what? R naught into 1 plus integral of alpha dt. Generally, we consider alpha to be a constant quantity. We can take it out and we can write R equal to R naught into 1 plus alpha delta t. Similarly, for resistivity also, the same relation is there. Rho f is equal to rho naught into 1 plus alpha into delta t. You can write it if you want. Yes, do you understand?
Yes, sir.
Can we move
Yes,
ahead?
sir.
Okay. Now, it is also possible that we take thermal expansion into account, right? So there will be two factors on which the resistance will depend. We know that R is equal to rho L by A. If I take log on the two sides, R will become ln R, rho will become ln rho, L will become ln L, and because there is a multiplication, so there will be a plus sign here. I hope you clearly understand. And A will become ln A, and because there is a division, so it will become minus. Is that clear? When we differentiate the two sides, ln R will become dr by R, ln rho will become d rho by rho, ln L will become dl by L, and ln A will become dA by A. Do you understand it? Now, this will represent the thermal coefficient of resistance, that is alpha R. And dl by L will represent alpha L into dt, that is the coefficient of linear expansion. Do you understand it? And dA by A is called the 2 times of linear expansion. Do you remember it? Yes? So they can write as minus of 2 alpha L. This is 1 unit, this is 2 units. So ultimately it will be alpha R minus alpha L into dt. You can write it. Yes. Alpha R is for resistance, thermal coefficient of resistance.
So I understand
The
how
alpha
it's
that we had written earlier, this is alpha R.
so could you show the next?
Okay,
Yeah,
tell
I
me.
understand how it's 2 alpha. Yeah.
This term, because the area is giving the, you remember there are three coefficients, alpha, beta, and
Yeah.
gamma. Alpha is coefficient of linear expansion, beta is coefficient of superficial expansion, gamma is the coefficient of volumetric expansion, and beta is equal to 2 alpha. You remember it? Gamma is equal to 3 alpha.
Yeah.
Do you
Yeah.
remember?
Yeah. Right.
That is what we are writing here. For area, we are writing 2 into alpha L.
Got it now, sir.
Actually, beta was written as alpha A, gamma was written as alpha V. If you follow the NCERT textbook, they don't use alpha, beta, and gamma. They write alpha L, alpha A, alpha V. That is why I've written alpha L over here. Okay, this is the value of dr by r, right? So dr will be r naught into this. Do you understand? But when we talk about the practical values, alpha r, that is the coefficient of thermal resistance, is approximately 10 to the power minus 2. And alpha L, the coefficient of linear thermal expansion, is approximately 10 to the power minus 5. So what is the conclusion? Alpha R is very, very greater than alpha L, 1000 times greater. So alpha R minus alpha L can be considered to be alpha R, and dr by r can be considered to be alpha R into dt. When we perform the integration, we get the same relation, r naught into 1 plus alpha. But in a specific question, if they want in terms of the symbolic values of alpha R and alpha L, then it will be not alpha, but it will be alpha R minus alpha L. Do you understand the difference? Yes or no?
Yes, sir.
If the linear expansion is to be taken into consideration. Why it is not taken into consideration? That is what I have tried to show here. Correct? But in a question, if they have specified that alpha L is to be considered, then instead of writing alpha R, we will write alpha R minus alpha L. So here also alpha R minus alpha L will be there. Here also alpha R minus. Is there any problem to anyone?
No, sir.
Can we move ahead? Okay, let us do a very simple question, very easy question. There are two parts of a conductor.
So please show the.
A is a uniform area of cross section. The first part has a length L, half of the part has a length L. It has a resistivity of rho 1, and alpha 1 is the coefficient of resistance. Rho 2 is the resistivity of the second section. Alpha 2 is the coefficient of resistance. The question says that what is the relationship between rho 1, rho 2, alpha 1 and alpha 2 so that the resistance of the system is independent from the temperature. Means when the temperature changes, the total resistance of this conductor does not change. The two sections are having the same length. The two sections are having the same area of cross section. Is the question clear?
Yes, sir.
So row 2, 2A,
Hmm?
the diagram,
Hmm.
it's row 2, right?
Yes, rho 2 and alpha 2. Rho 1 and alpha 1. For this section, it is rho 1 alpha 1. For this section, it is rho 2 alpha 2. Yes, Adi, tell me.
Sir, alpha 1 rho 1 plus alpha 2 rho 2 is 0.
Yes, excellent. Very good. Very good. Now, what is the practical situation in which this is possible? Can the both sections of the given system be conductors? Yes, Adi.
No, sir, they can't because alpha will be positive then.
Exactly. So one of the two alpha 1 or alpha 2 has to be negative. Correct? Meaning that if one section is a conductor, other section has to be semiconductor. Okay? Rho 1 and rho 2 both are positive quantities, but alpha 1 and alpha 2 should be opposite in nature. Alpha is negative for the semiconductor. So this was the initial resistance, rho 1 L by A and rho 2 L by A, right? These are the final resistances, rho 1 L by A into 1 plus alpha 1 T, rho 2 L by A into 1 plus alpha 2 by T. If the resistance has to remain constant with the temperature, then what we can say? The coefficient of delta T has to be 0. The coefficient of delta T will be rho 1 alpha 1 plus rho 2 alpha 2, and the result will be possible when one is conductor, other is semiconductor. I am writing alpha 1 equal to minus alpha 2 because I am assuming rho 1 and rho 2 are suppose numerically equal, but one has to be conductor, other has to be semiconductor.
So how did you get rho 1 alpha 1 plus rho 2 alpha 2 equals 0? I did not get that part.
The coefficient of delta T, if you try to find out, other terms will get cancelled, and the rest, if the coefficient of delta T will be calculated, it will be rho 1 alpha 1 L plus rho 2 alpha 2 L. That will be the coefficient of delta T. The coefficient of delta T has to be 0. It means rho 1 alpha 1 L plus rho 2 alpha 2 L has to be 0. So rho 1 alpha 1 will be equal to rho 2. Okay, any difficulties there? Well, now I hope you understand the concept of current density, right? And I told you that the current is what? Current density dot product of area. So if area is not perpendicular to the current, then what we have to do? We have to take the component of area that is perpendicular to the conductor or perpendicular to the flow of the current, and J will be written as I divided by A or I divided by A dash into cos theta. In the vector form, I is equal to J vector dot A vector. Here, if I'm talking about the area A dash, then it will be J A dash into cos theta. Current density is a vector quantity.
How is it A dash?
If the area to be considered is A dash, if the question is what is the current density associated with this area A dash, then we consider the component of area which is along the direction of flow of current, that is we consider the component A. Okay. If the area vector is along the flow of the current, no problem. Whatever is the area, that is multiplied to current density, and that will be the current. Okay? Right. I hope all of you understand the difference between EMF and the terminal potential difference. So what is the EMF? When we talk about the ideal state, then it is the rate at which the chemical energy of the battery is being converted into the electrical energy, right? So if it is marked that a battery is having 1.5 volt EMF, means what? When 1 coulomb of charge will pass through the battery, it will acquire 1.5 joule of energy. Any problem? That is called the EMF. Then we have the concept of potential difference. Potential difference is
So
general
can you show
term.
EMF for a
If
second?
there are 2 points, yes, what you want?
Can you show EMF for someone? Okay, sir.
When we talk about the potential difference, we are talking about the conversion of electrical energy into some other form of energy. That other form of energy can be heat energy, as you can see here. The battery is supplying the energy, it is being converted to heat in the resistor. It can be converted to again chemical energy, means the cell can get charged when it is connected in a circuit, right? Then it will still be considered as a potential difference, not as the EMF. Do you understand it? Suppose there are 2 batteries. One battery is having a EMF of say 10 volts, right? And there is another battery of EMF 2 volt, and there is a, you can say, 4 ohm resistance here. Then what will happen? The current will be supplied by this, but that current I is entering into this cell. So this 10 volt cell is getting discharged. Why it is getting discharged? Because the current is coming out of its positive terminal. And this 2 volt cell is getting charged. Do you understand it? So when the energy is converted into the 10 volt cell, it is converted from chemical energy to the electrical energy. But in the 2 volt cell, that electrical energy is getting converted to the chemical energy. In the 4 ohm resistor, the electrical energy is getting converted to the heat energy. So when I talk about the potential difference across this cell of 2 volt, I will call it potential difference, not the EMF. When I talk about the energy converted per unit charge for the 4 ohm resistor, I will call it potential difference, not the EMF. Is it clear? Understood?
So if there are 2 cells of same, like 2 volt and 2 volt,
Then there will be nothing will happen. There won't be any current in the circuit. Okay. So you can see in this diagram here, there is a 4 volt battery in which the electrical energy is being generated, means chemical energy is converted to electrical energy. It passes through one resistor where it loses 1 joule of energy per coulomb. So 1 volt is the potential difference. It passes through another resistor where 3 joule of energy is converted into heat per unit charge. So it will be 3 volts. Do you understand it? So this will be called the EMF of 4 volt. This will be called the potential difference. This will also be called the potential difference. This is the simple circuit. I hope you understand it. This is the EMF of the cell. This is small r represents the internal resistance of the cell, and capital R represents the external resistance connected across the cell. I is the current supply, that is EMF by R plus R. V is written as E minus IR, so that can also be written as ER divided by R plus R. Yes, have you understood? Can we move ahead? Great.
Yes.
Now we also have the concept of power and the heating effect. We know that power is work done per unit time or energy supplied per unit time. That can be written as V into I square into R, or V square by capital R. Do you notice it? Here our focus is on the external resistance. Have you written? Understood? Now when we talk about the variation of power with the external resistance, that is the external resistance, and if you are able to change the external resistance, then we know that I will be E divided by R plus R, where E is the EMF of the cell, small r is the internal resistance of the cell, and power output will be what? I square into capital R, that is E square by into capital R divided by R plus R square. And the power output of capital R will be maximum when capital R equal to small r, that is the internal resistance. You can, if you want, you can differentiate and you can check it. When capital R equal to small r, then this value of power will be maximum. Here, power is a function of resistance capital R. Do you understand it? So we have to find dP naught by dr equal to 0. When we solve it, we get this result. While differentiating, small r will be considered constant. Okay, do you understand? Any difficulty, any problem is there? Can we move ahead? This is how the graphically the power will be shown with the capital R resistance. And this is the point where the power has attained the maximum value. At this point, capital R has become equal to small r. I hope you can understand it. And the maximum power will be E square divided by 4R. I hope all of you are aware that tomorrow you have 2 slots of classes. Morning first slot is physics, mathematics, and that is 8:45 to 10:30, and second slot is physics 10:45 to whatever is remaining from this current electricity will finish tomorrow morning, right? And again next Friday we have again the physics class, second slot or first slot, first slot. And Saturday to hoga 2 class. Physics will be 1 class next means 1 week from now. Then we'll be going back to the electrostatics part, and whatever was remaining we'll try to finish. Okay, because this Saturday you have the current electricity test. Na? That is why I put that on hold and I started the current electricity part. Okay, this graph is clear to all of you?
Yes.
Can we move ahead? Yes, E square by 4R. This is the power 2. Here, power 2. I hope all of you remember the series combination of resistors. Rs is equal to R1 plus R2 plus R3. And parallel combination of resistor, 1 by R is 1 by R1 plus 1 by R2 plus 1 by R. In series, the value of R is greater than the greatest of the all. And the parallel combination, capital R is smaller than the smallest of the all. Okay? Ready? Yes. So now you have a very small circuit for your help. This can be done by different methods. Series and parallel is one of those methods. So try to find out. All of you are able to see the question clearly? Yes? Or any difficulties there? Tejasvi has joined. Tejasvi, Arepalli. Dadshini Perumal has joined.
So is it 14.4?
Syed Arsh has joined. एकदम पक्का? बोलो 14, 16. 14. Yes, Alan.
So I got 14.4.
Okay, then 14.4.
Why then? ये कल को डॉक्टर बनेगा तुम इंजीनियर बनोगी यार. Yes, Adi, what answer you are getting?
It's the same as Alan.
Yes, Ameya. Yes, Harsh?
Yes, sir, same.
What answer you are getting? Yes, 14.4 is correct. Very good. Excellent. Well done. So did you notice that 6 ohm and 3 ohm are in parallel? The equivalent of that will be 2 ohm, right? This will be the new circuit. Now this 2 ohm and 2 ohm will be in series. 4 ohm. That will be in parallel with 6. That will be. And when I connect them, what do I find? This will be 2.4 ohms. Any difficulty? And that is in series with 4 and 8. Yes or no? Yes. And the result will be 14.4. All of you clearly understand it? Any difficulty, any problem? Very good. Let us see this one. Again, a very direct, straightforward question. Your time starts now. Yes, Adi?
Is it 10?
Very good. Excellent. Wow. Alan, what you got?
So same.
Very good. Very good. Very good. Yes, Amia, what answer you are getting?
So I also got 10.
Very good. So you have to speak now.
Yes,
If you are
sir.
getting the answer, then you have to tell. Okay. So you understood? This is the first transformation. This 4 ohm, 5 ohm, and 3 ohm, they are in series. Their series combination will be 12 ohms. 12 ohm and 4 ohm is in parallel. Their equivalent will be 3 ohm. This 3 ohm and 3 ohm in series. Their equivalent will be 6 ohm. This 6 ohm and this 6 ohm in parallel. That will be 3 ohm. And that will be in series with 4 and 3. So it will become 10 ohms. Okay? All of you understood? Any problem? Now, sometimes we don't find the resistors in series or in parallel, right? So for that, we require a conversion that is called star to delta and delta to star conversion. Okay, write the heading. Star to delta and delta to star transformations. Have you written the heading? Okay. This is the star connection. In that, there are 3 nodes X, Y, and Z. And the resistance which is connected to node X is called Rx. The resistance which is connected to node Y is called Ry. And the resistance which is connected to node Z is called Rz. This is the star connection. Okay? Have you made this diagram?
Yes.
Then we have delta connection. This is like a triangle, right? We said a delta X, delta Y. That is like delta, correct? And the resistances between the same nodes, between X and Y, the resistance is R1. Between X and Z, the resistance is R3. Between Y and Z, resistance is R2. This is the delta connection. So generally, when deltas are present in the circuit, they make the circuit difficult, right? So mostly we convert delta to star. But sometimes star also make the circuit difficult. Then we convert star to delta. But that is in very less number of cases. Most number of cases, delta is converted to star. So have you made both the diagrams? The diagram showing the star connection and the diagram showing delta connection. In the star connection, we had the resistances Rx, Ry, and Rz. In the delta connection, we have R1, R2, and R3. Okay. So if I want to convert delta to star, then what will happen? The resistance Rx will be R1, R3 divided by R1 plus R2 plus R3. Meaning that if I'm talking about the node X, right? So in this delta, the two resistances which are connected to node X are what? R1 and R3. They will be multiplied and kept in the numerator, as you can see here. And all the three resistances will be added and will be kept in the denominator. Easy to remember. Whichever node we are talking about, the two elements or the two resistances which are connected to it, they will be multiplied, kept in the numerator, and all the three resistances, they will be added and they will be kept in the denominator.
So it depends on which one you're taking, right? Like if it's RY, then it will be different, right?
Yes, Ry will be R1, R2 by R1 plus R2 plus R3. Yes, Iqbal.
So this is one node over here, and in this other two resistors.
In series. So I will reduce it to 1, then I will apply it. We are talking about star and delta transformation for three resistors, right? In the case of a star, there are three resistors Rx, Ry, and Rz. In the case of delta also, there are three resistors R1, R2, and R3. Okay? So when I'm talking about Ry, what I will get? I will look at the node Y. This is the node Y, and the two resistors which are connected to it are R1 and R2. So we'll multiply R1 and R2 and keep it in the numerator, and sum of all the three will be kept in the denominator. Is that clear? So what is the value of Rz? Very good. R2, R3 divided by R1 plus R2. Is it clear? Yes? I hope you understand this is Rz subscript R2, R3. Actually, when I was trying to enlarge the size, वो 2 cut रहा था. That is why I kept besides it. Somehow there was a problem. Okay? Now, if we have to convert star to delta, then R1 will be what? Rx plus Ry into Rx, Ry by Rz. If I have to find R2, then it will be Ry, Rz into Ry, Rz by Rx. If I have to find R3, then it will be Rx plus Rz, Rx, Rz divided by Ry. That is how the star to delta transformation.
So which ones are in R2 and R3 here?
R1, R2, R3, the resistances in the delta network.
Whatever there it marked it.
These
Okay.
are R1, R2, and R3. If I want to convert this star network to the delta network, then this is the problem.
Yes, sir.
Okay, have you written? Understood? Very good. Let us look at this delta network. We have to find the equivalent star network. Means for junction A, I will find a resistance which will be connected here. For junction B, I have to find a resistance that will be connected here. That will be connected here. So when I go from A, I find these two resistors, RB and RC. I will multiply them. So the resistance here if I call it R1, so R1 will be what? RB into RC divided by RA plus RB plus RC. Is that clear? The shape is clear or not? The shape, अब आप कहोगे डेल्टा तो ऐसे होता था, ये ऐसे कैसे हो गया है? So it is उल्टा डेल्टा है. Similarly, if I call this resistor R2, then what I will do? I have to multiply RA with RC, RA into RC divided by RA plus RB plus RC. And similarly, if I call this resistor R3, then it will be RA into RB divided by RA plus RB plus RC. Do you understand how to apply it? Yes, who will tell me the value of R1?
5.
Sure? Very good. Who will tell me the value of R2? Very good, excellent. Who will tell me the value of R3?
6.
No. 3, yes. Very good. All of you understood? R1 will be 5 ohm, R2 will be 7.5, and R3 will be 3 ohm. Any problem to anyone?
Sir,
Yes, tell me.
do we need to know the reason or the derivation for this?
No. I'm saying that sometimes when we are trying to find the net resistance, we find the resistances connected in series and parallel. We go straight away and get the answer, right?
Yeah.
But sometimes inside the circuit, there are the stars or the deltas which do not allow we to apply the series and parallel formula. In such case, how to proceed? We cannot wait to apply the Kirchhoff's laws and to solve all the circuits, right? We don't have that much of time. Do you understand?
Yes, I got it.
So we convert the circuit to an easier format so that we can still apply the series and parallel formula. Okay?
So could you just show the circuit for a minute?
Yes, any difficulties there?
No, sir, I got it.
R1 will be 5 ohm, R2 will be 7.5, and R3 will be 3 ohm. And this is how they will be connected. R1 will be here, R2 will be here, R3 will be here. Okay? Right? Anyone having any difficulty? Okay, let us try one question. Convert the star to a delta network. So what will be the equivalent delta network? It will be like this. Yes or no? Presently there is a star, and if you convert it to delta, then this resistance we can call R12, that is, sorry, R13, that is between node 1 and 3. This resistance will be called R12, and this will be called R23. So for R12, what we will do? We'll consider the resistance here, R1, that is 1.67, plus other resistance, that is 5, plus 1.67 into 5 divided by the third resistance, that is 2.5. Yes, what is R12? 10 ohm approximately. R23?
Sir, 14.9.
That is 15 ohm approximately. And R31? 5 ohm approximately. Very good, excellent. This is how the conversion will take place. Okay? This is how the circuit will look like. Now we have to find the total current in the given circuit. Now here the problem is that this 20 ohm and 10 ohm, are they in series? No, because there is a current that is branching in this part here, right? 20 ohm and 25 ohm, are they in series? No, because the 10 ohm is causing the current to be branching. This 20 ohm and 10 ohm, are they in parallel? No, because this 25 ohm is connected across the two ends. So here in this circuit, we can't find any two resistances in series or in parallel. But I can focus on this part of the circuit here. This is a delta. Do you see a delta here? Three resistors, L, M and N. Bolo bache? So first we convert this delta into a star, right? Then
So
we
then
will
why
have
don't we consider
here
PML as
have a
delta?
resistor here. Bolo bache?
Why don't we consider PML as delta?
P and
PML, like the first rectangle, is delta.
any one triangle we
Okay.
can consider. We can consider this part or we can consider this part. I have solved using the right side. Okay.
Yes, sir. Yes.
Do you understand? So when I convert this, I imagine a point O over here, and I will get a resistance. You can say R1 here. I'll get a resistance, say R2 here, and I will get a resistance, say R3 here. Then this will be gone, this will be gone, this will be gone. Can you understand? Then this 20 ohm and this R1 will be in series. This 10 ohm and R2 will be in series. And these two will be in parallel. That will be in series with R3. That will be in series with this 2.5. And that will tell us the value of current I. Do you understand? Bolo bache.
Sir, the middle, the PMLN,
Haan.
can't that be taken as a star?
We can take a star also.
And then
Star to delta. But that will make the circuit little difficult. If I convert the delta to star, it makes the life easier. If I convert star to delta, it increases the number of junction points. If I convert delta to star, instead of 3 junction points, L, M, and N, I will have only one junction point, that is O. So delta to star reduces the number of junction points. Star to delta increases the number of junction points. Have you made the circuit diagram? And do you see a delta here? LMN is a delta, and we have to convert it to a star. So for finding R1, I have to start from point L. Do you see it? And from L, the two resistors are 25 and 10. So R1 will be what? 25 into 10 divided by 25 plus 10 plus 15.
5.
That is 250 divided by 50. That is 5 ohm. Very good. What will be R2? That is starting from point N. So it will be the product of these two resistors. I understand it.
1.5.
Very good.
7.1.
And R3 will be how much? Huh? 7.5. Excellent. Very good. So R1 will be 5 ohm, R2 will be 3 ohm, and R3 will be 7.5. Anyone having any problem? Now the circuit will become like this. The 5 ohm resistor which we had got will be in series with this 20 ohm. This 7.5 will be in series with 10, and this will be the 3 ohm resistor that will be left. These two series, and these series will be in parallel. That will be in series with this, and with this we have to find the value of I. Yes, tell me.
Sir, if in the question they ask that what's the current flowing through 20 ohm resistance, then is the first image fine? Like, can we use it to find the current?
Yeah. If we have to find resistance in a specific current in a specific resistance, then we have to find the point. This point. Zero point 9 के बाद कुछ बोलो, कुछ तो बोलो. ठीक है, 9. नाइन वन भी तो हो सकता था, 9 भी हो सकता था. Very good. Approximately it is 0.95 amperes. Is it clear? Yes or no?
Yes.
So could you show the answer for a second, just? Okay, sir.
Yes. This is the unbalanced Richardson bridge. P by Q is 1 by 1. This is 1 ohm. This is 1 ohm. R by S is 2:1. This is 2 ohm. This is 1 ohm. And there is a bridge resistance of 1 ohm. Do you understand it? All resistances are 1 except this one. This is 2 ohm. Yes. We have to find the equivalent resistance between the two ends. Is the question clear? If this resistance was also 1 ohm, then I will forget about this. These two will be in series, that is 2. These two will be in series 2. 2 and 2 in parallel, answer will be 1 ohm. End of the story. But here it is unbalanced. So again, we can find a delta here and convert that delta to star, just like the previous question. Can you see the similarity between the present question and the previous question that we had done? This part we had considered delta, right? And we converted it to a star like this, right? And once I converted to a star, I reconverted like this and I found the net resistance like this, right? So here also, this part you can consider as a delta, convert it to star, and then you can find the net resistance.
So you were saying about that if that was also 1 ohm, what was that method?
Then the Wheatstone bridge will be balanced. In that case, because of symmetry, the current will not go in this 1 ohm resistor. So we can remove this 1 ohm.
Yes,
Got
sir.
it?
Got it.
And this 1 ohm and this 1 ohm would have been in series, that is 2 ohm. This 1 ohm and this 1 ohm will be series 2 ohm. 2 ohm, 2 ohm in parallel, net resistance will be 1 ohm. End of the story.
Yes, sir. Got it.
Okay, circuit all of you have made?
Oh, it's one. Then look at that circuit. Okay, 2 plus 1 divided by 2 plus 1 is 3 by 4. 1 plus 1 by 2, 3 by 2, 1 by 2, 3 by 2, 3 by 2 and 3 by 2. That is 3 by 2.
I got R as 59 by 30.
3 by 4, 3 by 2.
50,
9 by 30.
30. That is not correct.
Sir, finish the question.
So I got 0.6.
Kirana, get the question.
No, the question. What? Nothing.
Net resistance we have to find. ये देखो कितनी अच्छी बच्ची है. हाँ बोलो. 3 by 2 is not the answer.
So what is the value of V?
No need. Because
So I
we
got
are
3 by
concerned.
5.
हाँ बच्चे?
3 by 5.
No, 3 by 5 is also not the answer.
3 by 7.
1.18.
1.19.
I have the answer in fraction. I think, yeah, 1.19. In fraction, what you are getting?
13 by 11.
Yes, excellent. 13 by 11 is the correct answer.
Yes, sir, that's 1.18.
Very good. This is the star delta theorem. What you want to see in the previous slide? Huh? This is the method. That was another method. That is nodal method. So these are the resistances. If I convert from the left side, I get 1 by 3, 1 by 3, and 1 by 3. This 1 by 3 and 2 will be in series. 1 by 3 and 1 will be in series. So this will become 7 by 3. This will become 9 by 3. And this is 1 by 3. They are in parallel. That will be in series with 1 by 3. So that will be 13 by 11. The parallel combination will be 28 by 30. Bolo bache.
Sir, if we take the star from the right side triangle, then we get the same answer, right?
Yeah.
We should get the same answer.
Yes.
Then can you do the conversion for the right side?
Ye do. If you are doing the conversion from the right side for this triangle, right? If I start from point X, I will multiply 2 and 1. That is 2 divided by 4. When I start from here, 1 into 1, that is 1 divided by 4. When I go from here, it will be 1 into 2, that is 2 by 4. 1 and 1 by 2, that will be 1.5. So this resistance will be 1.5. This will be 1.25. And that will be 0.5 here. 1.5 and 1.25 in parallel. That will be in series with 1 by 2. That will be 13 by 11. Okay, do you understand? चलो बहुत सारा सब्जेक्टिव टाइप क्वेश्चन हो गया. ऑब्जेक्टिव टाइप से दिमाग को फ्रेश कर लो. What is the SI unit of terminal potential difference?
Volt 3.
Very good. The dimensional formula of terminal potential difference will be
Two.
think carefully. I will tell you the potential difference V is equal to work done per unit charge. Work is ml2 T minus 2. Charge is I into T. So 2 is not a correct answer.
So is it A?
3 is yes. Option A is correct.
Oh, mine.
Wow, wow, wow. Wow. Could not see ये तो गलती नहीं है. इतनी मेहनत लगती है इक्वेशन टाइप करने में है. Yes, option 1 is correct. Any problem to anyone? No?
No.
Very good. Now we talk about the grouping of the cells. So if there are n number of cells connected in series, then what will be the equivalent EMF? E1 plus E2 plus E3 till En. And equivalent resistance will be R1 plus R2 plus R3 till Rn. लिखना चाहो तो लिख सकते हो. Yes, have you written?
Yes.
If there are n identical cells in series, then what will happen? The net EMF will be n into E. Net internal resistance will be n into R. Total resistance will be nr plus capital R, because capital R is connected across the combination. And the current supplied will be what? Ne divided by nr plus R. If the external resistance is very low, then I will be E by R. And if the external resistance is very high, then I will be Ne by R. The conclusion is that when internal resistance is negligible, then the cells are connected in series to get the maximum current. Okay, understood? Any problem? Yes, Alan?
Yes, I understood. No.
Any difficulty, any problem?
Yes.
Can we move ahead? So we also have the parallel combinations. So in the parallel combination, equivalent EMF by R equivalent will be E1 by R1 plus E2 by R2 till En. And 1 by R equivalent is 1 by R1 plus 1 by R2 till 1 by R. Any problem? Yes, have you written? And when we put the value of E equivalent, then E equivalent will be E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 .
So 1 by R1 plus 2 by R2.
1 by R2. 1 by R2. Okay, understood? And this is the cells in the parallel combination, identical cells. Okay, any difficulties there? No? Can we move ahead? Then we have the concept of Kirchhoff's law. I hope you remember it. Kirchhoff's law says what? At a junction point, if I1 is coming, I2 is also incoming, I3 is outgoing, I4 is incoming, I5 is outgoing, then what we can write? Incoming is positive, outgoing is negative. So we'll write I1 plus I4 plus I2 will be equal to I3 plus I5. The algebraic sum of currents is 0. Okay. So Kirchhoff's law of junction is in accordance with conservation of
Charge.
what? Very good. याद है? लेकिन अब दोनों ऑप्शन दिया हुआ है तो क्या करोगे? Then both A and B. Primarily it is conservation of charge. It is also called law of conservation of. यहाँ करंट नहीं है, so we'll say conservation of charge. Got it? Then we had the Kirchhoff's voltage law. I hope you remember it. So in a network, this is a resistance R through which the current I is flowing. So if I go from A to B, I will write plus IR. If I'm going from B to A, I will write minus IR. Is that clear? For a cell, if I'm going from A to B, I will write plus E. If I'm going from B to A, I will write minus E. Any problem to anyone? So this is a circuit. So from the cell E1, I1 current starts. From E2, I2 current starts. According to Kirchhoff's first law, it is I1 plus I2 that flows through the resistor R3. Again, the current distributes. I1 and I2 goes in the different parts. Do you understand it? There are two currents, I1 and I2. So we'll take two loops. We first consider loop A, B, A, D, C, B, A. So in the loop A, D, C, B, A, what I will write? When I go from A to D, I'm going in the direction of current I1. So I will write plus I1 R2. When I go from D to C, the current is I1 plus I2, resistance is R3. I'm going in the direction, so I'll write positive. Is that clear? When I'm going from C to A, there is a current R1, there is a current I1, resistance R1. So it is plus I1 R1. But negative terminal of cell E1 has came first, so it will be minus E1. That will be equal to 0. Is that clear? Yes. Similarly, when I take the other loop D, C, E, F, D. D, C, E, F, D. When I go from D to C, I get a resistor R3. Current through it is I1 plus I2. So I'll write plus I1 plus I2 into R3. Then I cross the resistor R5, again in the direction of current I2. So it will be plus I2 R5. Then I cross the cell E2. The negative terminal is coming first. It will be minus E2. Then I cross the resistor R4 with the current I2 in the direction. So it will be plus I2 R4. Yes, understood? The summation will be 0. Any problem is there? No, sir. Can you see the circuit here? This method is the combination of superposition principle and Kirchhoff's law. In this, what do we see? We decide the current flowing in the whole loop. Meaning that in this loop, the current is I1. In this loop, the current is I2. In this loop, current is I3. Not through the individual resistors. Do you understand? Now, when I talk about the 10 ohm resistor, what do I notice? I1 is going in this direction. I2 is going in this direction. So the net current through it will be I1 minus I2. Do you understand it? For the 5 ohm resistor, I1 is going in this direction, I3 is going in this direction. For this 5 ohm resistor, current will be I1 minus I3. Do you understand it? For 3 ohm resistor, I2 is going in this direction, I3 is going in this direction. So for the 3 ohm resistor, current will be I2 minus I3. Are you understanding it? For this 2 ohm resistor, the current is simply I2. Do you understand? For this 1 ohm resistor, the current will be I3. This is called the superposition principle used with the Kirchhoff's law. Because because we don't have the time to write the equations. Do you understand it? If it is a CBSE exam, then we have the time. We can neatly make the diagram and we can neatly write the current in each element. But when we are doing for the MCQ type question, we have 1 minute time to solve it. So in 1 minute, we can't write I1 minus I2, I2 minus I3. So that we take the mesh, the superposition principle, right? So you can write it, make the circuit. Okay, I would again like to call Tejasvi is here. Tejasvi Arepalli, Dakshini Perumal, Syed Arsh Kinath. Have you understood? The current in the different loops and the current in the different elements, how to relate it. Okay? So this is a homework for you. Try to solve it. Tomorrow morning we'll meet again. And I hope that by that time you will be able to solve the questions. Okay? Take care of your health. Bye-bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Sir, I wasn't able to